Welcome to my talk about the aPart framework. Thanks everybody for attending directly after lunch break, even though we have the term framework in the title. Before I tell you more about the corporate logos you see on the starting page, I'll give you a short overview of what you will hear. First, I'll talk about the motivation. Why do we implement a framework? Who's behind? What's the target of this framework? What are the basic concepts? Where are we now and what do we plan? So the motivation. In the right top you see the logo of Schmidt Bureau for Civil Engineering, a German company located in the federal state North Rhine-Westphalia. And Schmidt has about 40 employees on 5 locations. Most of them are civil engineers. And many years ago, Schmidt started the in-house implementation of a document management system to support the daily work of the engineers. So for implementation, of course, Schmidt chose Smalltalk, and it started about in the late 90s with an early release of VisualWorks. And now the interesting point for nowadays, Schmidt applied for a research project that is sponsored by the institutions you see at the top, at the bottom, the logos of the EFRE.NRW and of the European Union, the Forum for Regional Development. And EFRE is the abbreviation in German for the same, so it means European Forum for Regional Development, and it is limited to North Rhine-Westphalia, to the federal state, and that's the reason why Schmidt tried to get that research project sponsoring. We got this project and it was a really success story. Schmidt could almost double the team size for this project, and the supervisors of the EFRE were really supportive. They were very helpful. You could ask them for changing some order of execution of the tasks to be done. You could also even introduce new ideas during the project. So one interesting point, only to show you this, last year I got in touch with Doro about his human assessment at the ESUG in Maribor and learned more about his software assessment techniques through multiple tools. And we managed to get a 2 days in-house workshop in Dortmund this year, in February, about his tools, and learned very interesting things that are across platforms of Smalltalks to be applied to our own application cases. So even this was sponsored by these institutions. But the framework I'm talking about here is far less than 10% of the whole volume of the project. Roland Wagner from Hague will give you in his talk tomorrow an overview of what else is done in this research project. I will limit myself to the topic of the framework. So our framework targets the creation of, the implementation of business applications. And what do we understand here? So we think of a business application as something with the application area of a domain-specific solution. In our case, a document management system, including invoicing for civil engineers, for example, but not limited to that. The framework is independent of the domain of the application. The architecture we're supporting is a database-centric architecture, typically a 2-tier system, no application server, but direct database access from FAT clients with a platform-specific GUI. That's our approach. Now, to narrow this down further, from the perspective of application specs, what do we have typically before we start to implement such an application? We have main business objects, general business rules, some functional requirements that have to be implemented, and they will define which use cases we create, which database design we apply, and which user interfaces we build. When we implement such an application, we normally apply some specific patterns. Typically, we have class hierarchies for main components that are typically connected to GUI windows. We have reusable sub-components of different kinds, like widgets, tables, models, even abstract models. Of course, we have hierarchies for database-related objects. And we also use some specific access patterns or APIs to do things within the application, like for opening interconnecting components, providing access to global information, and dealing with the database, of course. Transactions is the most important topic here. So at the start of the research project, that was the point when I joined the team. That was in 2016. And we had a long-grown application with a lot of code, and of course there was already a lot of stuff implemented for document management and handling of civil engineering tasks. And now we had the idea, okay, the new project should rely on a significantly wider technical base than the old, because we want to do something also in the cloud. That will also be the topic of tomorrow from Roland. So the only thing that was clear was we would have to reuse only the core of what is there and functionality, and there was the need to extract this functionality somehow. So if you do something like that, looking for business rules and use cases in existing code, there are some key questions arising. First, maybe how strong are these rules and use cases connected to the application environment? Can you isolate them somehow? Next question is, how easily can they be changed or expanded? And the most direct question in this case is, where are they located in the code? So every piece of software has an underlying construction independently of what you try to implement. And the way you construct your software has a significantly high influence of what you can do with that later. How do we construct is the question. I try to illustrate this by talking about the construction of a wooden house like you see in that picture. So let's assume we start with raw material, trunks of trees that we cut down somewhere in the wood, carry them out, and then we start to build our little house. First we have a basis of walls and connectors at the edges of these walls. And the way to shape these connectors is not trivial, but if you do it right, then you get a stable construction. Then we have a look at the openings like doors or windows. What we see there is we put some vertical frames up there in order to provide attachment points if we later want to close those openings and attach some doors or windows. And finally, the roof is constructed in another different way. The roof tiles should be tightly attached and perfectly shaped in order that they protect us from water and snow coming from above. So, in a nutshell, the approach of construction is taking what you have as a raw material and reshaping it. It's funny that Doro today also talked about reshaping, the developer experience, so today is reshaping day, I think. And when we reshape, everything is fine. And normally we as developers think of that we constructing like this way. But is this really the case? Well, I have seen a lot of software in the last decades, and what I more often found than the construction we saw before is a construction like in this picture. And that's the way I think we end up when we do not reshape what we have at hand, but desperately immediately try to use the pieces we found as good as possible, as direct as possible. And if you started once like that, you will not easily get to a construction like we saw before. That's almost impossible. But anyway, you try to refactor and reshape and correct the construction, but what you will end up like is more like this picture here. So it's not, anyway, it's not a good construction. And you might think, okay, the guy here is overdoing. Reality is not as bad as it's drawn here. But in fact, I've seen more nasty cases like that. Think of several floors of the same construction piled up over each other, and you are asked to join the project and come in there, and you're searching for some polite wording to tell the manager, well, I would not really recommend to expand this kind of construction, but the manager is totally enthusiastic and says, our customers all want balconies. How can we attach balconies to this construction? And that's reality. So I'm not overdoing, I'm in fact trivializing reality about here. So let's compare those two things. I call this at the left side as an entangled construction, because everything is connected to each other in a way you cannot easily tell which part depends on which other part. And of course, it's obvious, such an entangled construction makes it harder to locate functionality, to assess existing dependencies, and especially to estimate cost of changes or extensions. If you think of changing the position of the door or window from left to right, it would also be not an easy task based on the right construction. That would also be not easy, but at least we can exactly plan what we want to do and how it can be done. On the other hand, there are also surprisingly good reasons for starting with an entangled construction, because the raw material is just there, and trying to construct like on the right side is only possible if you have a lot of experience in the team. Think of creating the logs that are all equally shaped out of raw tree trunks. Think of the skills needed to shape the corner points such that they really work, and all that stuff. There's a lot of sawing and smoothing needed before you can construct like in the right picture. You might even need something like a sawmill, and who has that at the start of such a project? So there is a reason to start without framework. I tried to illustrate this with this diagram. The blue line shows the throughput of feature implementation and maintenance if you start first by implementing your own framework. So obviously at the beginning, for a long time, there will be no feature implementation throughput at all, because you have to start with a framework. Whereas if you directly implement, you have a much better throughput. On the other hand, this is slower over time, but even if you compare those two curves, the area underneath them, over the time I've drawn that here, this might be almost the same size. So your throughput overall might be almost the same when you start with a framework or without a framework. But there is one further reason to avoid entangled software, and that's what I've drawn in the next diagram. So this is a fictional scenario where we have the y-axis as the team size and the x-axis as the time here in month to illustrate the idea I want to show. Let's assume the left part of the diagram we do not see is something over 1 or 2 years where a team of 2 guys implemented something and they were quite productive. It was a small team, they talked to each other and they had the same idea how to implement software and how to maintain this over time. And at some time the management decided, well, we want more, we need a bigger team. But the software style was mainly dependent on those 2 guys. So if you now start to increase the team size, like I have shown here, to 4 or 5 people, you will for a certain time be very low in your productivity. Why? Simply because the only guys that know the old stuff are totally busy with telling the new guys how to do things and cannot be productive by themselves. And this will be a painful long period where you have a lot of more people in the team, but you will not be able to get the right output. And it comes even worse, and that's what I did not draw here. If you really struggle and try to push the productivity very early as possible, then you will get another effect that's very bad over a long time, because the new guys will do the work just as they like. Nobody has time to introduce them, and they have no time to coordinate them with the way the core team from before started doing the stuff. And what will be the output is another level of entanglement that's different from before. So 2 kinds of entanglement starts mixing up. And that's really the issue I encountered a lot of times when I came into projects that lasted 10 years or longer. We found a lot of crazy stuff. You couldn't imagine how this could have come into production. And I think this kind of entanglement over time, entanglement dimensions over time, that's the really issue that leads you to a point where you can only drop big pieces of software because it's no more possible to normally refactor them. And knowing that, I tried 2016 to define something that is a lean construction, not something totally new, throwing everything away and starting from scratch. That would be nice, but it's not possible in most scenarios. I think it's not so important which kind of architecture or design patterns or whatever you use when you start implementing a framework or basing software on a framework. It just has to make sense. And one thing I desperately want to avoid is connecting things that are not really to be connected. And so the title of my framework, of this talk, was the aPart framework, separating GUI and use cases. And as I was unable to find the use cases in the old software, I said, okay, let's find a way how we can separate the basic items and to finally represent use cases as real classes. And so we came up with this architecture. You're missing only one rectangle at the bottom, and that's not important because it stands for your subclass of aPart. Then what you see here, pointer somewhere, it's a small diagram, it will go without. So the center, the bottom center is the class aPart. That means this is a kind of component within a business application that contains values, actions, whatever you want to expose. So I define business application as something building modules that expose something, because we have clients that are those boxes at the left side. Won't go into details, but the idea is that they totally are separated from the right side in a sound way, and you can do GUI like you want, like you always did, but every logic has to be independent, defined by parts. And the main secret is aPart defines what it exposes. It defines values, it defines actions. When you press on a button, what has to happen. If it's an editor, then an action might be save, the save key. And what we underestimated totally in the beginning was the conditions, because all actions and the change of values are underlying specific conditions, and those are elements of the business logic of our project. So what you have to do in the aPart framework looks really very simple at that moment. You have to define your subclasses, mostly of aPart, and then you have to expose and then you have to expose your conditions, your values, and your actions. And the aPart interface is the one entity that does the management of all those exposed values and coordinates the communication, including everything like announcements of changes and all stuff. It provides the access to the models that the GUI needs in order to display values, to change values, and so on. And your part, as the main object, here this one of your special class, this part class is the one that should work without any GUI. That's the main idea of that. And now, before I show you where we have the use cases here, interestingly they are not part of this diagram, I give an overview of what we have as participants and roles within this aPart framework. On the modeling level, we have the parts that are forming the skeleton of the application. They contain objects that are exposed, like conditions, values, actions, and of course stuff that is private to them as they like it. aPart also can use any class and should not use something directly associated with the GUI. On the UI level, we have generic GUI clients that are provided by the framework because they do the elementary communication. And we have a lot of application-specific objects. We don't care about them. It's just so that we have to have a modeling counterpart of them. So if the GUI comes up with some specific widget that needs a model, then we have to provide this model, and otherwise this widget would not be supported. And then there is an interesting thing. We have something third, I call it the glue level, but put this term in quotes because I could also think of it as a detail level. It's not necessary to get everything together, but it can contain arbitrary objects. And when we designed the use cases of the application, we found that the use cases belong to that glue level. And the good news is the aPart framework does not make any prediction how these use cases are to be implemented. They can be implemented as you like it, with your own object hierarchy, but there is one interesting thing about the use cases, they are typically created by parts. We found that this is the natural approach for creating use cases because the parts are an abstract skeleton of the application. They hold the actions, they define the actions that are possible, and the use case typically starts when you try to execute that action. So we decouple the whole nasty stuff. How does it come from the GUI over the model that reacts to the button and ends up in the action? Even the action is a class of the aPart framework, but what the action does is totally free, of course. Normally you have a code block there that is provided by the part, and if the part decides, well, if this action is executed, I instantiate a specific use case, provide this data, and the use case runs, then the separation is perfect. And what we really like as a pattern is to have the use case be totally independent of direct access to the parts. It's much better if you provide all the data that the use case needs to run. Why? Because of testing. If you write tests, it's very perfect if you do not have any connection to existing hierarchies of whatever, and having the use case navigate up to parent objects and desperately trying to fetch his data. So a use case does not reference any part typically. It's initialized with all object needed for running, and the special trick to get some information that where the need occurs at runtime, like override yes or no, this special trick is done by so-called callbacks, so that the use case expects his creator to provide a means to get those data. And this little trick makes it possible under the normal GUI environment to provide the dialogue where the user can enter yes or no, select yes or no. But if you have a test suite running, then you provide a callback handler that directly puts in the answer true or false. And that's the way how to keep use cases totally independent from any environmental basics. So if we look at the advantages we have by this approach, we have advantages on level of the application feature design. First thing is, might be overlooked in most cases, but a clear definition of what a part exposes, because this is simply part of the application logic. We have a well-defined setup of parts and subparts. That's the point where the class hierarchy of parts makes sense, because it defines in which order the different sub-elements are initialized, and the, how many? 10? Okay, fine. I'm almost through. And the definition of this setup is very crucial. In fact, if you have a larger application, you immediately run into the problem that you have contradictions concerning the order of what to initialize first and last, or you run into problems like the performance of initialization is bad because you initialize too many database-related objects and so on. And if you force yourself to follow the pattern of the parts, then you immediately are forced to work on this application-specific problems, because that's a problem that is specific to the application you're implementing. If your data should better be retrieved not all at once, and if you have a complex hierarchy of objects where one object at the lower level depends on its parent somehow. So that's the point you find out. And we made a good experience with this restriction to the parts. I mentioned already the best practice for use cases, that they reference data instead of parts. And of course, you have use cases as defined anchors of functionality within the application. Think of a document management system. There's something like create document. And if I remember the code of the system when I joined 2016, and I wanted to find out how to create a document in this document management system, you might find some hook, but then following senders and implementers and senders, you get lost in several places and access to some global data where you don't guess how they come up and so on. Now it's much easier because by definition the use case is created by somebody, might be a part in most cases. You look, okay, that's the way how this use case is initialized, and that are the data I have to provide if I want to instantiate the same use case. And then you find immediately the points that are interesting. And of course also the internal framework functionality brings up some advantages. Instead of doing everything by yourself, only as far as it's needed at some corner of your program code, you have a high stability of basic functions that are all the time reused for init, shutdown, and broadcast and all that stuff. And we carefully looked at every part of our framework does not introduce nasty dependencies where you have to change the same things at different positions in code, so that what we call narrow hooks. We do not repeat ourselves as you might know the anti-pattern try. And if you reuse this, you are also on the good side, because you do not have to reinvent the same stuff all the time. So, where are we now? The aPart framework in its current state is implemented under VisualWorks 8.2, with the 8.3 coming soon, but it doesn't depend really on the release or especially on VisualWorks, despite from the GUI connection part. At the moment, we use it only for new documents, for the new document management app, but we have already a wide variety of complex scenarios that we support there. We do have simple examples for all important basic features of the framework in the shape of example classes that are running, and you can of course debug them and read them. We have even a reference solution for dealing with tracheel shapes. That was one task I had to solve, to have a graphical editor for workflow shapes that are connected via lines and so on. And I also tried to find patterns to apply this part scheme even to dealing with the tracheel shapes, and it worked very well. And we took some advantage of our action concept for all those nasty stuff like shifting shapes around the canvas and attaching lines and all that stuff. And one thing that's also very nice, as we have a semantical level of what happens in the system, because we have exposed actions and exposed values, that means what comes in from outside can be registered, can be noticed. And that's the point where you can attach something I call a recording client, and this recording client notices every executed action and every value change, and I implemented it in a way that if you set up a recording client for use of creating testing code, at the end of your recording period, you get the full code of a testing method that you can immediately paste in a test class, because it recorded every change and every announcement of state change of conditions, so the test can, when it runs, check if somebody executed this action and changed these values and so on, then the conditions changed in this and this way and will fail, the test will fail if the conditions do not fulfill the prediction. So unfortunately we have no overall documentation, and the comments of the classes are still in German, because at project start it was all with German comments, but that can be changed easily. But anyway, the framework in its state as it's now needs a thorough cleanup before it is useful for other people. And thus, what is our schedule? For 2019, we hope that we can clean up and refactor everything we have in context of the current application. So the framework is also a kind of separation where we are able to distinguish between what are we doing on application level and what are we doing with our technical base. And those two paths are really independent from each other. And we will improve the support of generated GUIs in our version of VisualWorks, because generated GUIs is another big advantage you can immediately reach by using a framework like ours, because as the logic is completely separated from the GUI, you can define anything, any way that you think is convenient to create GUIs that you don't have to do by hand. So in 2019, we will also start with the file report and documentation in Pillar. And what I heard today from Doro makes me really enthusiastic about the ways to integrate our examples into the runnable documentation, I call it that way. In 2020, the year after, we are hoping to have a full-featured reference example, including database handling with Glob, so that the documentation does not only include simple things, but we will also have a reference example that's also for testing reasons, because if you have complex objects there, then it's easier to do that on basis of a reference example and of the real application you are dealing with. And of course we will then also try to have a unified code base, which is not very difficult because we follow our own rules within the framework, of course, and separate things. So let me close this talk with some visions. What if creating a small business app takes only a few days? Normally you have to do so much useless stuff you're doing all the time and only do small variety of the same things. And what if such a business app is not a prototype but production quality at first try? So that's really one of my goals, to provide classes around the core of the framework that support you doing business applications in a way that the output is really on a professional level. And this is amazingly almost the same like Doro was aiming today. What if developers prefer to use a framework instead of following their usual habits? So the early phase of implementing or defining a framework, that's not always fun because you have a very limited scale to support, and the developers of the team, on the other hand, want to produce application code, of course, and so you always have to convince them, okay, we do not support everything and the support is not perfect, but please use it anyway, and that's not a good state. And really, sometimes it really reminded me simply the separation of GUI and model and all the details coming with that. It reminded me, I felt myself in a role like parents that have teenage children and they ask them to clean up their rooms. So that was the similar experience for me, because one of you, our parents, might notice that the teenagers will answer, I don't see why I have to clean up my room. And translated to software means, okay, yes, it's a good idea to separate, but we don't need to. And then on the teenage level again, the teenagers sometimes say, okay, I will clean up my room once, but don't expect me to change my habits. And that's the point where I want to follow Dora's advice for the future, so that I once can convince developers to use the framework. That was my vision. Thank you for your attention.